Okay, so this is the handout that I would normally talk with you about in class, but since we don't have class, I'm going to just make a little recording and insert this into the Nearpod. So there's a couple other things in here that we aren't going to be really discussing. We just have learned about and are only going to learn about the first three methods: the disc method, the washer method, and the cylindrical shell method. This kind of has it all in one little spot for you, to, depending on if it's rotating around the x-axis or the y-axis. I know I had to make a change here, but I can't remember exactly what was wrong on here that I had to write this in, but I think it's all matching. I think it's all good now. So three different methods. Does it matter which method? Can we use any method on any problem? I mean, technically, maybe. I mean, there are some cases where you just simply cannot use the disc method. But it is a really easy method. And I think you can use the shell method just about any case. I don't know. There's not really anything coming to my mind that I can use it for, but there seriously, literally are some cases where you could not use the disc method. The disc method you can use whenever the area or the region is flush up against the axis. Okay, so as long as if I have say, something maybe let me just do a parabola like this. Okay. So if I'm rotating that around the x-axis this way, then disc method works because my little discs are each going to be individual like this. But it wouldn't work for me to do it around the y-axis. I wouldn't be able to use the disc method because this function is not flat. Y equals -2 because there's a gap here. Or if I want to do around y equals 4 because there's a gap here. Okay, so the disc method only works when the region, which could be bounded by more than one function, is flush up against what it's rotating around. Okay, the washer method, you can use it when it's not flush up against an axis, and actually you probably don't want it flush because the idea here is that you're subtracting, like there's a gap. There's a gap somewhere between one of the functions and the axis of oscillation. I keep saying axis of oscillation. The axis of rotation. Different thing, right? Okay, so not washer method. Now, I don't know if you've thought about this, but for the cylindrical shell method, or the shell method, it's cylinders. The cross section is going to be parallel to the axis it's rotating around. Okay, so up here I was talking about the disc method. So the discs are like this. So if say I'm going across the x-axis, the discs are like this. It's a series of discs. The function represents the radius of those discs, so it'd just be the function squared, and it's flush. Whereas if we're doing the volume of this particular graph, and I was using the shell method and rotating around the x-axis, then my shells are going like this, and the cross section is actually parallel to the axis. When I did the disc method, the cross section was perpendicular. For the shell method, the cross section will always be parallel to the axis of oscillation. And you can use this when there is a gap between the function and the axis of oscillation. So these two can both be used when there's a gap between the axis of oscillation and the function itself. Axis of rotation, I keep saying that. But this one has to be flush. Okay. So, but often there is more than one way. Say I were to have a function where there's really two different regions. I'm trying to think of something off the top of my head here. Like let's say maybe it goes like this, and then maybe it goes straight, and I want to rotate it around the x-axis. Okay. So in this situation, I could use the disc method because it's all flush against the axis, and I could have my discs, but I would have two different integrals. I'd have the integral for this parabola, and then I'd have the integral for this straight line. So there'd be two different integrals. Could you maybe do something like this, rotate it around the x-axis with another method and not have to do two integrals? Is it possible? Could you do a shell method on that? The shell method, so it would have to run parallel the cross section, like here would be a cylinder. Would that be a possibility to do it with 1? Then your radius would be your y coordinate. I don't know if it would, because you really would have one function for y that's changing, and then over here it'd be constant. So I don't know. I think you would probably still have to break that one into. But I know there are some that you could do with the shell method in 1 integral that would only work with the disk method in 2. So watch out for that as you're going along here. Okay. So that's a little synopsis, and a nice little sheet I attached so that you could kind of have all the formulas in one spot. Don't forget that you can use a difference. You might have this radius here even being represented itself as a difference between two things, in addition to a subtraction between the two functions. Okay, that's always an option. We've seen some problems with the shell method where maybe y doesn't represent the radius, but maybe 2 minus y does. Okay, so don't forget that you know, representing that measurement could involve subtraction between an integer and the function, or the function and an integer, or even 2 functions for that matter. Okay.